All right, guys. Welcome to the final part, guys. The last 15 questions, number 36 to 50. All right, we're going to be subtracting another polynomial. Same concept, guys. We're going to be distributing this -1 to the polynomial to the right. So this negative 2x squared becomes positive 2x squared. This negative 4x becomes positive. Plus 9 becomes -9. Bring down the first parentheses at x plus 9. Combine our like terms, right? There's no other 2x squared, right? So that's going to go first. The highest exponent first. And then we have 8x and 4x, same terms, which is 12x. Then we have 9 minus 9, which kind of zeroes out. So we don't have to bring down the 0. So we're done. Because plus 9 is like you have $9 and you spend $9. So it kind of zeroes out. So let's move on. Adding polynomials. So adding polynomials is a little easier than subtracting. There's like an invisible 1 here that we will distribute, but when you multiply 1, you just pretty much just get rid of the parentheses, right? Now combine your like terms. We combine those two. -8 plus 7 gives us -x cubed, right? -1. And then we have -3x and -8x, which is -11x. And then we just have the -2, bring that down. And there's no other terms, so we're done. None of these are like terms, so we can't combine those. So we're done adding. All right, let's keep going. Number 30, add or subtract whatever we see, right? But PEM does process from left to right. So we're going to combine these two first and then subtract this one. So we're going to distribute this -1 here and then just drop these parentheses. So then we get 3x squared plus 4x minus 1 plus 2x squared plus 6x plus 18. And then distribute this -1, so we get minus 5x squared plus 11. Now that we have all the operations simplified out, we just combine like terms at this point. So it'll be 3x squared with 2x squared with minus 5x squared. 3 plus 2 is 5. 5 minus 5 is 0. So guess what? The x squares cancel out. Or 0 out. And then we have 4x plus 6x, which is just 10x. And then we have -1 plus 18 plus 11. So you owe me $1, but you pay me 18, so I give you 17 back for you to spend. 17 plus 11 is 28. 10x plus 28. Looking at the answer key, and we're done. Yeah, we're good. Do not get tricked by the signs, guys. Make sure you write down this little lines just to show my like terms and what I can combine. Number 39, finding the product. So now we're doing multiplying polynomials. We're going to do 9y minus 8 times another 9y minus 8. We're going to use arrows here. So we're going to do 9y times 9y, which is 81y squared. And then 9y times minus 8 is -72y. -8 times 9y is another -72y. Then -8 is a +64. Combine our like terms here. So then we get 81y squared minus 144y plus 64. And let me double check that. And we're good, yeah. Ooh. Here we have a binomial with a trinomial. So I'm going to introduce to you guys the box method. So we have a 2 by 3. So 2 by 3. So it's going to be 3 columns and 2 rows. So then the rows is x plus 7. And then the columns is x cubed minus 3x plus 5. It's a multiplication table. X times x to the 4th. X times x cubed is x to the 4th. X times -3x is -3x squared. X times 5 is just 5x. 7 times x cubed is 7x cubed. 7 times -3x is -21x. 7 times 5 is 35. The only like terms we have in this problem here are just these two here. So let's write them out, right? So it equals to x to the 4th plus 7x cubed minus 3x squared minus 21x plus 5x plus 35. Combine these two like terms, what do we get? And then we get x to the 4th plus 7x cubed minus 3x squared minus 16x plus 35, because negative 21 plus 5 is negative 16. And we're done. Let's keep going. So here we have 3x minus 11, 7x plus 1. Multiply these two, right? So then be smart about it, right? So it'll be 3x times 7x, which is 21x squared. 3x times 1, which is just plus 3x. Negative 11 times 7x, which is negative 77x. Negative 11 times 1 is negative 11. Combine our like terms, so then we get 21x squared minus 74x minus 11. And we're done. Don't overthink the multiplying. You know, we've done distribution before, so this is just like distribution, but now it's like a little more complex a little bit. So just don't overthink it. Here, this is a difference of squares, because the formula is a plus b, a minus b equals a squared minus b squared. So this is a plus b, and then this is a minus b. So to use the special rules is we're going to square a minus square b. So what does that look like, right? So it'll be a squared, so it'll be 3x squared minus 4y squared. So 3x squared is just 3x times 3x, right? So 3 times 3 is 9, x times x is x squared, right? And then for 4y squared, it will be 4y times 4y, which is 16y squared. Which will be negative 16y squared. And we're done. Now you want to multiply them out using the arrows. 3x times 3x is 9x squared. 3x times minus 4y is negative 12xy plus 12xy minus 16y squared. The 12xy's cancel out, leaving you this answer again. So I'm just reminding you of the tricks we learned in class. So you do you with how you want to do this, guys. You do want to know the tricks though, have in the back of your mind. Let's keep going. Number 43, use FOIL to multiply, which is just the same concept I've been doing with the arrows. 3y times y is 3y squared. 3y times 5 is 15y. This is the F, and this is the oil, and then the O, and then this is the I. Negative 7y. And then last is negative 35, which is the L. These are like terms here, so then we get 3y squared plus 8y minus 35. And we're done. (5x minus y squared). This is also a formula, guys. This is a minus b squared, which is just going to be a squared minus 2ab plus b squared. This is a minus b, right? So this is going to be a squared, right? So it'll be 5x squared minus 2 parentheses 5x parentheses 7 plus 7 squared. 5x times 5x is 25x squared. Negative 2 times 5 is negative 10. Negative 10 times 7 is negative 70x. Don't forget the x there. 7 times 7 is 49. And we're done. Now you could have done this very similar to number, I believe it was number 39. Just write them down, 2 parentheses, right? The same parentheses, 5x minus 7 times 5x minus 7. You should get the same answer, guys. I'm just reminding you the formula. The other formula we learned in this class was a plus b squared is equal to a squared plus 2ab plus b squared. Alright, here is another same thing of a minus b times a plus b. So this is the difference of squares. A plus b, a minus b equals a squared minus b squared. So is this vice versa though? So this is a and this is b. A and b. So then we're going to do a squared, right? So it'll be 5x squared minus 1/5 squared. 5x times 5x is 25x squared. 1/5 times 1/5 is just multiply the tops with the tops, bottoms with the bottoms. 1 times 1 is 1. 5 times 5 is 25. So this is minus 1 over 25. And we're done. do not overthink these guys. You could have just multiplied them out using the arrows too. Same concept. Some terms are in the middle are gonna cancel, and then you'll just get these two these two left over. But look how much nicer it is with the formula. Less arrows, less steps. Number 46. Now we have negative exponents, and we have other rules to apply. Here we have before we do the 3 one, we're gonna go ahead and do the inside. We're gonna simplify the inside. So we're gonna do quotient rule. So remember, the rule is x to the m over x to the n is equal to the x m minus n. So first things first is gonna be x negative 4 minus 2, right there, times y 5 minus 9 to the third power. We're just combining the x's and the y's. What happens there? We get x to the negative 6 times y to the negative 4 to the third power. We're now going to distribute this 3 to both the 6 here and to the negative 4. So then we're going to get parentheses x to the negative 6 to the third power, y to the negative 4 to the third power. So now we have a power to a power. When we have a power to power, that's the power rule. We're going to multiply those bad boys. So then we get x to the negative 18 times y to the negative 12. We cannot have a negative exponent in the final answer, so we're going to go ahead and put that over a fraction of 1. And then now the x goes to the bottom with the 18 becoming positive, and then the 12 in the bottom, the y in the bottom, with the 12 becoming positive. And we are done. Our final answer cannot have yeah, so here we are. All right, we're here now. So 47. Same thing, guys. We have quotient rule, right? The bases are 2 and x, right? So let's apply the quotient rule. So it'll be 2. What are we subtracting for the 2's? Negative 4 minus 2. Wait a minute. Top minus bottom, guys. This x doesn't have an exponent. What do? It has a 1. So then it'll be negative 3 minus 1, right? So it'll be 2. Negative 4 minus 2. You owe me 4, spend 2. So now you owe me 6, right? And then negative 3 minus 1 is negative 4. Remember, final answers can have negative exponents, so make a fraction over 1. And then the 2 goes in the bottom now and becomes 2 to the 6. And then we do x in the bottom, which is 4. But remember, it wants us to simplify. So guess what? 2 to the 6 can be a value. It's 2 times 2 times 2 6 times, which is just what? 1 over 64x to the 4th. And we're done. All right, let's push through, guys. We're almost done. Oh, we're dividing polynomials. So this one's a simple principle rule that we learned in the lesson for dividing polynomials. What we do is make 3 fractions, 12x to the 4th over negative 12x to the 4th minus 8x cubed over negative 12x to the 4th plus 5 over negative 12x to the 4th. So let's go ahead and simplify these, right? So the first things first is we have to simplify the fractions, right? The numbers here. And then we do the quotient rule for these here. So let's do it. So 12 divided by negative 12 is negative 1. X, and then we subtract the exponents, 4 minus 4, top minus the bottom. Negative is a positive. 8 over 12, I believe we divide that by 4. There's 2 4s in 8 and 3 4s in 12. And then we're going to go ahead and subtract the exponent. So 2/3 x, 3 minus 4. And then 5 over 12 does not simplify, so it'll be minus 5 over 12. And then there's no x's there, so it just stays in the bottom. So we simplify this subtraction problem. So it'll be negative 1 x to the 0 plus 2/3 x to the negative 1 minus 5/12 x to the 4th. So the last fraction is good, right? There's no negative exponent, no 0 exponent. Here we have the problem. X to the 0, though, is just equal to 1. So we can actually get rid of that bad boy. And then x to negative 1, we have to move to the bottom of a fraction to make it positive. So then we get negative 1 plus 2 over 3x with a positive 1, which can be invisible, 5 over 12x to the 4th. Now there's no negative exponents or 0 exponents, and thus concluding our work here. Do not overthink these guys. Do not overthink it. Don't think that there's more to it. Just put them into fractions, simplify the fractions, do the quotient rule if you can. On the last fraction, we weren't able to, so we know we're good there. Because you ask yourselves, are there negative exponents? Are there zero exponents? Now look at our final answer. There's none of anything. So no negative exponents and no zero exponents. All right, let's move on. Find a quotient using long division. This gets juicy. So we do x plus 2 divided into x squared, 7x squared plus 16x plus 4. So then I taught my class a little differently about this. So I had them circle or highlight this term here. And then we're going to go ahead and box this term here. So what we want to do is x times what equals 7x squared. That's the logic behind this, right? X times what? Well, it's x squared, so we need an x. X times, there's a 1 here. 1 times what is 7, which is 7. So this is going to be 7x here. Then we have to multiply this 7x to the left side. So 7x times x is 7x squared. 7x times 2 is 14x. So then we make them the opposite. Since they're positives, they both become negatives. These cancel out. If this does not cancel out on the first thing, then you pick the wrong thing here. So then this cancels out. 16 minus 14 is 2x. Bring down the plus 4. Now we do this logic step. Now we box this one in. So we do x times what is 2x. Well, this should be a times 2, right? So x times 2 is 2x. So this is a plus 2. We're going to distribute that back. 2 times x is 2x. 2 times 2 is 4. They're both positive, so we make them negative. This cancels out, this cancels out. So that's a 0. There's a 0 remainder. So the answer, the quotient is 7x plus 2. All right, let's finish off this bad boy, guys. So now we're going to do long division again. So x minus 2. And then we have 3x squared minus 2x plus 5. So we're going to go ahead and circle this one and box this one. So then we're going to do x times what equals 3x squared. And we need an x and then a 3. So it'll be 3x. Multiply this back to the left. So 3x times x is 3x squared. 3x times minus 2 is negative 6x. So now we switch sides. Positive becomes negative and this becomes positive. And then these cancel out. So then we get 4x plus 5. Bring this down. So now we're going to box this one. So now we want x times what is 4x? Well, that's a positive 4. We need a positive 4. Multiply that out. So then we get 4x again times negative 2 is negative 8. We're going to go ahead and switch the signs now, right? So it's going to be positive becomes negative. Negative becomes positive. So these cancel out and we get 13. This 13 is our remainder. So there's two ways to write our answer. So we can write 3x plus 4 remainder 13. Or the college way that I want you to focus on is 3x plus 4 is a positive 13. So it'll be plus 13. And we have to divide it by what we divided by. Which is this bad boy here. So then we're going to get x minus 2 on the bottom here. And this is our final answer. Please take a look at these examples, guys. If 49 and 50 did not make any sense to you, you don't think you can do that on your own, the same process, then we watch the 12.6 lesson, review your notes, guys. Go to the math app for help. Thank you so much, guys, for tuning in. Good luck on your finals, and peace and love, everyone. Take care.